problem C, group C problems, whatever, we've got parallelograms. A parallelogram, as you can see in this little diagram, we usually think of it as kind of a rectangle that's been kind of squished over to the side or something. It is a type of quadrilateral, meaning that it has 4 sides, in which the opposite sides here are parallel to each other. And that's what these little red arrows mean. The ones that match up, those two are parallel. The double arrows here meant those are parallel. Now, in addition to that, we'll see properties of parallelograms also include the fact that the opposite sides are not just parallel, but they're also congruent to each other. So this one says it's A. This one over here would also be A. The bottom down here, which we call the base B, is also the same length as this one up here. Heights and bases, they always have to make right angles. They need to be perpendicular to each other, which is why you see this right angle here. So you want to look for that whenever you're doing any problems involving the area for parallelograms, because that's usually a base and a height kind of thing. Okay, so parallelogram has side lengths A, B, and C. What? A, B, and C? Where's this C business? I haven't a clue. And a base B and a height H. So at least we have these things written here. Occasionally a problem, and I think the problem that we're going to do here shortly has these two given to us, and we have to in some kind of way figure out what the height is supposed to be. All right, the perimeter is supposed to be 2 times A plus 2 times B. Why is that? It's because those two, the two B sides are the same and the two A sides are the same. Okay, and then the area is just simply the base multiplied times the height. The base multiplied times the height. Again, just like we talked about in one of the previous videos, area is going to have square units attached to it, and then perimeter is going to have singular units attached to it. And again, it's easy to think about it in terms of the units because the base here might be in inches, and the height is in inches. Inches times inches gives us inches squared area. That's what happens. But for the perimeter, you have inches plus inches. When you add inches up, you still get more inches. When you multiply, yeah, sure, you're going to be squaring stuff, but when you're adding, you just get more inches. So let's take a look at the problems that we have for parallelograms. And we have, find the perimeter and the area of the parallelogram below, and it's been graphed for us. We have some sort of graph grid. Strange thing about this one is going by 2s instead of by 1s, but you know, whatever, we'll deal with it. Number 2, solve the parallelogram perimeter formula for 1/2. What? Let me go back to this. There's not even a 1/2 in it. I don't know. We'll figure it out. All right. Number 3, the area of a parallelogram is 12 square root of 6 centimeters squared. If its base length is 2 square root of 3 centimeters, what is the length of its height? Man, this would probably be a pretty easy question if the numbers weren't so complicated. So we may have to talk about in a little bit of detail how to deal with those strange, irrational kind of numbers like that. So let's get started on these problems. Find the perimeter and area of the parallelogram below. So for perimeter, we'll start there. For perimeter, I need A and B. And A is one of the side lengths, and B is the other side length. I need those two things in order to calculate it. And remember that these things go by 2s. So this base length here is 2, 4, 6. It is 6 units. And that, when you're on a graph grid and it doesn't give you units, that's what you write. You just write U for units. It's generic. All right. Now, I got a bit of a complication here, and that is this. I want this side length here that's diagonal from B to C, but you can't just measure it by just counting 1, 2, 3. Whoops, here, let me do it all over again. 1, 2, 3, 4. That didn't work. You don't get to count diagonally, and the reason why you can't is because of the Pythagorean Theorem. Speaking of, that's what we have to use in order to find this side length from B to C. That's right there. I am going to imagine that there is a right triangle over here on this right side of this shape. I'm just going to drop this thing straight down, bring this segment across. Maybe I even color it just to make it look pretty. Okay, so what I do know is that the bottom of this right triangle is it's one box, but one box represents 2 units. So it's a 2. And then vertically it is 1, 2, 3, 4. 4 times 2, it's 8 units high. And then I'll need to use the Pythagorean Theorem in order to solve for the length of BC. And I'll just call this, for the sake of this problem, I'll call it a C, because that's what I'm used to on the Pythagorean Theorem. All right, so I'm going to quickly run out of space for this particular problem, so I'm going to add a page to this so I have some room to write on that. Okay, so just for that particular problem, Pythagorean Theorem goes like this. C squared is equal to a squared plus a b squared. The c is what I'm looking for, the hypotenuse. My a and b are interchangeable. It doesn't really matter which one is which. I'll use the 2 as my a, and I'll use the 8 as my b. So it's 2 squared plus an 8 squared. And now just solve this by combining some like terms if we have any, taking square roots. You know how the Pythagorean Theorem works. 2 squared is 4. 8 squared is 64. Gives me a total of 68. Okay, the last step on the Pythagorean Theorem, of course, is to take the square root of both sides. So taking the square root of both sides of this, c is equal to the square root of 68. And the square root of 68, I know, is not a perfect square. It's not a whole number. And the reason why is because it's in between the square root of 64, which is 8, and the square root of, let's see, that's 8, 9 is 81. It's in between there someplace, right? So it's not a whole number. So what we can do on this is leave it like that to get an exact answer. We could put it into the calculator to get an approximate answer, or we can rewrite this if it can be simplified. So this is what I mean by this. You may have done this in algebra last year, just a little bit. Square root of 68. I've got a couple of ways to tackle this. I can look for a perfect square that divides evenly into 64. That would be one thing to do. Or I can just factor this thing and look for some like repeated factors. And it is an even number, which means 2 goes into it. Just divide it by 2 and I get 34. Okay, and then 34 is also an even number, so I can divide it by 2 again and get 17, I believe. So in this particular method, I have a pair of 2's, so one of those 2's gets to come out, and then the 7 is left all by itself inside the little square root, the radical symbol, 17. Right, and the reason why that works is because 2 squared, 2 times 2 is equal to 4, and really this is the square root of 4 times the square root of 17, and the square root of 4 is that 2 that's right there. So there you have it. Man, that took forever. I haven't even finished this problem yet, and I just got the side length. I'm going to write that on there. That's 2 square root of 17 in the place of c. 2 square root of 17, and it also has like u on it, units. Okay, and now to find the perimeter of this guy, the perimeter, I have 2 of this base length down here of 6, right? Let me come back over here. It's 2 A's and it's 2 B's. Plus, I have 2 of these 2 square root of 17's. And now I need to, kind of clean this up and simplify it a little bit. So 2 times 6 gives me 12. My perimeter is equal to 12. And I want you to think of this like in a special way. 2 square root of 17, think of it as like 2 times x, where x is that square root of 17. This is going to be kind of a very helpful strategy for these kind of problems that have square roots in them. If I were going to multiply that by 2, the only thing that really gets multiplied by 2 is the other 2 to make this 4x. So I'm going to do the same thing with these little square roots. I'm only going to multiply this 2 and the 2. The 17, the square root of 17 is going to function like this x. I'm not going to leave it alone. So this is going to be plus 4 square root of 17. And that's it. I would leave it just like that. Sure, it's acceptable for you to put that into the calculator to get an approximate answer. And I'll show you that in just a moment. Okay, so units, because it is perimeter, those are singular units. So let's punch stuff into the calculator. The calculator loves to be punched. It's like a punching bag. As a matter of fact, I can open them both at the same time and then just type it in that way. So I can see stuff that I'm supposed to be typing in. I have 12 plus 4 square root of 17. And you can see the answer popping up right there. Now notice that there's no little convert to fraction bar like there is on this one. And the reason why is because this number is irrational. If your number is irrational, you cannot turn it into a fraction. It's like a key property of irrational numbers. So if you had solved this in your calculator with an approximate answer, there's what the decimal expansion would look like. You just write down a couple of decimal places. But I would suggest that what you do when you write down a problem like this is that you use the little approximately equal sign. And then what is this? 28 point, I'll give 2 decimal places, 49. 28.49, still with units at the end of it. Okay, that's good enough. All right, wow, how long is this video going to be? Because we haven't even tackled the area yet, but that's no problem. Area, I think, is just base times height, right? Base times height, as long as they make a right angle. So my base and my height, what are they? Here is my base length right down here. It's 6. And then my height has to be perpendicular to it. It needs to be, say, this length right here. But I'm pretty sure I already figured that out. It's that number right there. It's 8. So 8 is my height and 6 is my base length. That's what I'm going to go with. So I will write down here, down below, I'm going to write that my area is equal to base 6, height 8. No calculator necessary. We got 48 and throw in our units squared. Again, whenever you're on a graph grid and it doesn't indicate any units, just use some generic ones. Or if any particular problem outside of the coordinate plane, if they don't give you any units, just throw in the generic u squared on it, okay? All right, so I'm going to pause this video right here. We will pick up number 2 and number 3 in the next one.